Okay, so go ahead. Is your number 1 the same as mine, or is it shuffled?
Now let me check.
It's the same.
Okay, awesome. Perfect. Okay, so in the figure shown below, the 2 triangles are congruent and the 2 rectangles are congruent. Both the congruence of the triangles and the congruence of the rectangles can be exhibited with 1 or more sequences of transformations. So using kind of what we learned last unit, we have to answer which of these can be exhibited with a translation followed by another translation. So remember, a translation is a slide. So which one could we slide twice? The rectangle, if we slide the rectangle twice, would we end up with the other rectangle or the triangle? If we slide the triangle twice. Yeah, right. The rectangle, we could slide it down and then we could slide it to the right and then we would end up with this rectangle, right? Would that work with the triangle also? Could we just slide the triangle down and then slide it to the right to get this triangle?
No.
Nope. Exactly. Perfect. So which of these can be exhibited with a translation followed by another translation? Only the congruence of the rectangles. Which of these can be exhibited with a reflection followed by another reflection?
Triangles.
The triangles. Very good. Yep, if we flip this triangle across the x-axis and then flip it across the y-axis, we'll end up with this triangle. Very good.
Would the rectangles work the same way though?
Let's see, we have 1, 2, 3, 4. So go 1, 2, 3, 4. Yes, it looks like both. And the rectangles, that's right. So both the congruence of the triangles and the congruence of the rectangles. You're right, both it would work. So we could flip across the x-axis and then flip across the y. Yep, reflect again, and we would end up with the rectangle as well. Very good. Rosalie, any questions on number 1?
No.
Okay, we'll go to the next one. All right. Figure A is congruent to figure A prime. Complete the sentence that describes the 2 transformations that could be performed on figure A so that figure A maps onto figure A prime. Choose words from the drop-down menus to correctly complete the sentence. So perform a reflection across the x-axis or the y-axis. Which one would we want to do first?
X-axis.
Yep, the x-axis right here. We'd want to flip across the x-axis and then translate it up, down, to the left, or to the right. So that's sliding it. Which direction do we need to slide it then?
To the right.
To the right. Brendan, you've been doing your work. You've got it.
I try my best.
Very good. You're on it. Okay, figure A prime is rotated 30 degrees clockwise about the origin to create figure A double prime. Okay, it's not shown. So which statement about figure A prime, and figure A double prime is true? So only figure A is congruent to figure A double prime. Only figure A is congruent to figure A prime. None of the figures are congruent, or all of the figures are congruent. So let's start. Are these 2 figures congruent? Figure A and A prime?
Yes.
Okay, and then now we're going to rotate A prime. Is that new figure congruent?
Yes.
Yeah. Right. When we're doing these transformations, they're all congruent. The size doesn't change, right? That's only when we start getting into dilations, which hasn't come up yet. So what do we know about all of the figures then?
They're all congruent.
They're all congruent. Very good. Okay, here we have trapezoid A, B, C, D, and then we have a triple prime, B triple prime, C triple prime, D triple prime. Okay, so are they congruent? If so, describe a sequence of rigid motions, so of transformations that prove that they are congruent. Well, let's just look at them. Are these two trapezoids congruent?
Yes. Well, no.
No.
They're
Okay.
similar.
They're good. Okay, they might be similar, but are they congruent? In order to do rigid motions, they would have to be congruent, right? Because the size and the shape doesn't change when we do those. So let's see. Is it possible that there was just a reflection and then a translation? No, so we know it's not this first one. A reflection and then another reflection? No, because again, the size has changed, right?
Yes.
So no rigid transformations preserve parallel lines, and AB is not parallel to, I don't think so. Let's look at this last one. No, all rigid transformations preserve distance, and the side lengths of trapezoid A, B, C, D are different from the side lengths. So that's what we said, right? If it was rigid transformations, then the size of the trapezoid wouldn't have changed. So that would be this one. Since these side lengths are different from this one, it wasn't just non-rigid transformations that took place. It was a dilation, like Brendan had said. They're similar, or we think there could have been a dilation that took place because it clearly shrunk, but that's not the kind of transformations they're talking about. Any questions on this one?
No.
Okay, triangle EFG has points E, F, and G. It's dilated by a scale factor of 1/3 with a center of dilation at the origin to create triangle E prime, F prime, G prime. Which graph correctly shows triangle E prime, F prime, G prime? So how would I do that? What do I need to do to these points to figure out what the new points are going to be? So how can I figure out like what E prime would be? So if E is 4, 6, to get E prime, hi Lily, we are just going through the test together. So if you want to hop on the unit exam from today, we are on question 4. Okay, any ideas how we get our new points? So our E prime point. So we use the scale factor that they gave us. So remember, if the scale factor was 2, then we multiplied all the points by 2 to get the new points. In this case, our scale factor is 1/3. So to get E prime, we're going to have to multiply for our X value. We need to multiply 4 times 1/3. And then to get our Y value, we need to multiply 6 by our scale factor of 1/3. Does that look familiar? And then we just multiply across, so we get 4/3. And then we multiply across here and we get 6/3, which is 2. So this point would be 4/3, 2 for E prime. F, we have -9, -6. So then to get F prime, the X value, we need to do -9 and take 1/3 of that, or multiply it by 1/3. So we get -9 divided by 3, which is -3. To get the Y value, Y is -6, so we need to multiply that by our scale factor, which is 1/3. So we get -6 divided by 3, which is -2. So this new point would be -3, -2. Why don't you guys go ahead and tell me what you get for G prime? So G is 3, -6. Go ahead and find the X value and the Y value of G prime. Rosalie, did you get the X value?
No, not yet.
Okay.
Does the X equal 1?
X does equal 1. Perfect. Yep. We take our X value, which is 3, and we multiply it by our scale factor of 1/3, which is just 3/3, which is 1. Excellent, Lily. And for our Y value is -6. So we multiply that by the scale factor of 1/3. -6 divided by 3, we just multiply straight across, is -2. So our new point would be 1, -2. And so now we just have to find the graph where E prime is at 4/3 and 2, where F prime is at -3, -2, and G prime is at 1, -2. And I'm not sure your answer choices are shuffled. Do they look the same as mine, or are they shuffled?
I just got back, but they look to be the same.
Okay. So which one matched our points?
The second one.
The second one, let's see. So if we go to 4/3, remember that's 1 1/3. So it's just after 1. And then it would be at 2. So the E prime, oh wait, sorry, that's not the second one, right here. So here, and then it would be here would be E prime. So I don't think it's the second one. We've got to find E prime at just past 1 and 2, which for me is the last one. And then let's check F and G. So F is at -3, -2. Yep. And G is at 1, -2. Yep.
Yeah, I guess the answers are a little shuffled then.
Oh, okay. Yours was the second one. So check the points on your graph then. Make sure that it has all, the second ones are easier. Check F and G. Make sure F is at -3, -2, and G is at 1, -2.
Yep.
Oh, I didn't mean to hit that next. Okay. Moving on to 5. Triangle ABC is dilated by a scale factor of 2 with a center of dilation at the origin to create triangle ABC. Okay, so how are we going to figure out the points of our dilated triangle?
Are you gonna multiply each point by 2/1?
Perfect. That's exactly right. Our scale factor is 2. So just like the last problem where our scale factor was 1/3, we multiplied all the points by 1/3. So now that it's 2, we're going to need to multiply each of these points by 2. Very good. So this is number 5. So the first point, A, is at -2, 4. And so now we just need to multiply. This one's easier math. We just have to multiply the x value and the y value by 2. So negative 2 times 2 is negative 4, and 4 times 2 is 8. So our new point is negative 4, 8. And then point B is at negative 3, 1. So B prime. So Brendan, if we multiply by 2, what's our new point going to be?
Negative 6.
Yep. And for Y?
Negative, or 2, sorry.
Very good. And for C, Rosalie, let's see, we have 3, 2. So then C prime, I need to multiply by 2. So what's my X value going to be? Oh, maybe Rosalie's not there. Lily, can you tell me what we would get for C prime?
Sorry. C prime would be 6 and 4.
6 and 4. Excellent. We'll multiply by 2 and we get 6 and 4. So now let's just find the triangle that has those points. So A is at negative 4, 8. B prime is at negative 6, 2. And C prime is at 6, 4. So for me, it looks like it's the first one. So check the points, just make sure those are the 3 points. Any questions on number 5?
Nope.
Nope.
All right, number 6. Point P has the coordinates negative 2, negative 4. It's dilated with a scale factor of 3. So what are the coordinates of P prime? So what do we need to do to figure out P prime?
Multiply negative 2 and negative 4 by 3.
Perfect. And so P prime will be negative 2 times 3, which is
Negative 6.
negative 6. And negative 4 times 3, which is
Negative 12.
negative 12. Very good. You guys have got these dilations down. Okay, here we have our rectangle. ABCD is similar to A double prime, B double prime, C double prime, D double prime. So the similarity can be shown by a dilation from the origin of the rectangle ABCD followed by another transformation. So what is the scale factor of the dilation and what is the next transformation? Select options from the drop-down menu to correctly complete each sentence. So to show similarity, first perform a dilation to rectangle ABCD with a scale factor of what? So if we want to make this rectangle the same size as this one, what's our scale factor going to be?
A scale factor of 1/2, or is it just 2?
Of 2. Yep, because if we want to make it bigger, so it would be 2, right? And you can kind of look just by counting the sides, see how this the length of this side is 3 and the length of this side is 6. So then we know, what do we need to do to 3 to get to 6? We need to multiply by 2. So it would be the scale factor of 2. And then do we need to perform a translation of 8 units up, a reflection across the x-axis, or a reflection across the y-axis? So now we're going to have, if we multiply this point, this is 1, negative 1. We multiply that by 2, then we're going to be at 2, negative 2. So A would be down here. So our rectangle is going to be right about here. So what would we need to do to map that rectangle onto this rectangle?
Reflect across the x-axis.
Reflect across the x-axis. Beautiful. Very good. Any questions why it's a reflection across the x-axis?
Nope.
Okay, very good. Okay. Juan maps triangle LMN onto triangle L prime, M prime, N prime using two transformations. He first uses a dilation centered at the origin, followed by a translation. So select from the drop-down list to correctly complete the sentences about the two transformations. Okay, so the scale factor of the dilation. So what do we need to do first? What's the scale factor going to be to get this triangle to be the same size as this triangle?
3.
It's going to be 3, right? And so first, let's figure out those new points. This is number 8. So we have L, which is at 1, 2. And then we have M, which is at 2, 0. And we have N, which is at 1, 0. Okay, so first we need to multiply all of those. We'll do double primes. We need to get this the same size. So first we are going to multiply by 3. So 1 times 3 is 3. 2 times 3 is 6. And then 2 times 3 is 6. 0 times 3 is still 0. And 1 times 3 is 3. And 0 times 3 is still 0. Okay, so now we have to picture that point L is at 3, 6. So first, the scale factor of the dilation we said is 3. Then the translation is how many units to the left? Well, let's look at point L double prime. So if we're at 3, 6, we need to translate it 1, 2, 3, 4, 5, 6, 7, 8 units to the left. Any questions about those first two? Okay, and then these transformations show that triangle LMN and triangle L prime, M prime, N prime are both similar and congruent, neither similar nor congruent, similar but not congruent, or congruent but not similar.
Is it both similar and congruent?
So since this one's smaller than this one, they're not congruent. They are what?
Similar.
They are similar. Yep. So they are similar, but not congruent. Does that make sense? I know, because our new triangle that we created would be congruent, but they're just talking about LMN, this triangle, and then this triangle, L prime, M prime, N prime. So they are similar, but not congruent. Okay, which of these statements is true about the two graphed parallelograms? So we have A, B, C, D, and then we have A prime, B prime, C prime, D prime. So are they similar? If so, what's the scale factor? Or are they not similar? So we kind of just have to look at the points to determine whether or not they are and what their scale factor is. So A it helps to just list the points. A is at 2, 8. And then A prime is at 1, 4. And we'll do one more point just in case. So B is at 6, 8. B prime is at 3, 4. So we could do all of the points just to make sure. C is at 8, 4. C prime is at 4, 2. D is at 4, 4. D prime is at 2, 2. So what are we doing with our original points to get the new points? What's the scale factor?
A scale factor of 1/2.
Yep, of 1/2, and that works for all of them, right? 1 is half of 2, 4 is half of 8, 3 is half of 6, 4 is half of 8, and so on. So are they similar?
Yes.
Yes, and their scale factor is 1/2. Okay, number 10, this is the triangle sum theorem. Do you guys remember what the triangle sum theorem says?
All the points will add up to 180.
Yep, all the angles in a triangle always add up to 180. So we just need to set up an equation. So we know that angle A plus angle B plus angle C equals 180. So angle A is 2x, angle B is 40, and angle C is 3x. And that equals 180. So then how am I going to solve for x? What do I need to do? Anyone know how to solve? What do I need to do first?
Combine like
Combine
terms.
like terms. Very good, Lily. So 3x and 2x is 5x plus 40 equals 180. So we subtract 40 from both sides. 5x equals 140. We divide by 5, and x equals, I'm not sure what 140 divided by 5 is.
It's 28, yeah.
Looks like 28. Thank you. So x equals 28, but now they want to know what is the measure of angle A. So angle A is 2x. So we have to do 2 times 28, which is 56. So angle A would be 56 degrees. All right, number 11, this is the exterior angle theorem. So do you remember the relationship between angle A and B and this exterior angle out here, BCG? Anyone remember? No? So the exterior angle theorem says if you have this angle and this angle, these two interior angles are equal to this exterior angle. So angle A plus angle B is equal to this outside angle C. So first we need to solve for x. So 3x, that's angle A plus angle B, which is 4x, is equal to this exterior angle 10x minus 45. Any questions about how I set that up? Okay, so then we just simplify so we can combine our like terms, 3x and 4x, which is 7x equals 10x minus 45. And then Rosalie, do you know what I would do next to solve for x? Maybe Rosalie's not with us anymore. Brendan, do you know?
No, I needed help with this stuff.
Okay, so we need to get all the x's together. So we would need to subtract 10x from both sides. So then we get negative 3x equals negative 45. And now you know what to do here, Brendan. Now what do I need to do? How do I get rid of this negative 3 in front of here?
Subtract or add 3.
It's being multiplied, so how do I undo my multiplication?
You have to divide it.
Yep, very good. Yep. We do our inverse, which is division. So we get x equals negative 45 divided by negative 3, which is 15. But it's not asking what x is, it's asking the measure of angle B. So angle B is equal to 4x. So we have to plug in our x, 4 times 15, which means angle B is 60 degrees. Any questions on number 11? Okay, number 12. So we have these two triangles. Is triangle ABC similar to triangle XYZ? So select from the drop-down list to correctly complete the sentence. If the measure of angle Y is 60 degrees, then the triangles are or are not similar. So let's see. We have a right angle and this one's 60 degrees. And then we have X, Y, and Z. So if the measure of angle Y is 60, so if this one over here is 60, are the triangles similar or are they not similar? So if this angle C is 60 degrees on this one, so the right angles, these corresponding angles are equal, but this angle C is 60 and this angle Y is 60. So it might help us maybe to figure out this angle. So remember the triangle sum theorem, so they all add up to 180 degrees. So if this one's 90 and this one's 60, that means those two angles are 150. So what's the measure of angle B?
30.
Yep, so angle B is 30. And then remember, similar triangles, their corresponding angles are always equal. So the same angle in the same triangle, the angles have to be the same, even if the sides are larger or smaller. So angle A and X, those corresponding angles are equal, but angle C and angle Z, that means this one's 60 and this one's 90. This one would be 30, right? So are those corresponding angles equal?
No.
No. So are these similar triangles?
No.
Nope. So these are not similar. Okay, now if the measure of angle Y is 30, so now if this one's 30, then we know that this one's 60, right? Now, would these be similar? Are all of these corresponding angles equal? Well, we have 90 and 90, 60, which corresponds to Z, which is also 60, and B is 30, which corresponds to Y, which is 30. Are these triangles similar?
Yes.
Yes, then the triangles are similar. So to show the triangles are similar, you must show that one corresponding pair of angles has equal measures, two corresponding pairs, or three corresponding pairs of angles have equal measures. What do you guys think?
Is it 3?
Yep, all three of them have to be equal.
That's what I thought it might be.
Yep, we just showed that, right? Because A and X were always, that was 1. When 1 is if the other 2 are not, then it's not. It has to be all 3 of them in order for them to be similar. Okay, which angle pair relationship shows that 2 lines are parallel? So 2 alternate interior angles are supplementary, 2 corresponding angles are congruent, 2 vertical angles are congruent, or 2 adjacent angles are supplementary. So we're looking for parallel lines. We want to show that line A and B are parallel. If we have 2 alternate interior angles that are supplementary, does that prove they're parallel? 2 corresponding angles are congruent, 2 vertical angles are congruent, or 2 adjacent angles are supplementary?
I'm not sure what supplementary means. Could you explain it?
Sure, yes. Supplementary means that the 2 angles add up to 180 degrees. So say, 2 adjacent angles are supplementary, say this angle 1 and angle 2, that they add up to 180 degrees. Would that show that A and B are parallel? It doesn't help us, right? Because it doesn't show us anything for B. So we can rule that one out. If we have 2 alternate interior angles, so alternate interior, they're on the opposite side. So 3, 4, 5, this would be 6. Here's alternate interior angles. Are alternate interior angles supplementary? Do these 2 add to 180?
No.
No, these are equal, right? So it can't be that one. So now we're down to if 2 vertical angles are congruent, well, that could be 2 and 3. These are vertical angles. If those are congruent, does that show that these lines are parallel? No, because it's only showing us for it's only giving us angles for one of our lines. So all that's left is 2 corresponding angles are congruent. So if we know that angle 2 is equal to angle 6, that means all the rest of these angles are congruent. Because once you have that angle, then the vertical angle, we know that it's equal to this angle. And then these would be supplementary, which means this one would be equal to this one. And so that proves that those 2 lines are parallel. Any questions on 13? Okay, so here it's telling us that line N is parallel to line P. We have to drag each pair of angles into the group that identifies them. So alternate interior angles. Let's see, theirs are labeled different than what I did in that one. So let's just go through. So 1 and 5. So we have angle 1 and angle 5. Are those alternate interior, corresponding, alternate exterior, or vertical? So 1 and 5, these two. No ideas? So just kind of think about it. These are kind of exactly what I see them. So alternate interior angle. So it means it's inside of the line. So alternate interior would be something like 2 and 8. Those are inside of our parallel lines and they're on alternate sides of the transversal. So like 2 and 8 would be alternate interior, 3 and 5 would be alternate interior. So it looks like we can drag 3 and 5 to alternate interior because we can see that those are on alternate sides of the transversal and they're inside the two parallel lines. So those are alternate interior. So corresponding means if you look at them individually, it's the same angle on that line. So see how this one is on the top right of line N. Angle 5 is the top right angle of line P. So those are corresponding angles. This angle corresponds to this. It's the same angle, just on a different line. It's the same angle of line N as 5 is on line P. So 1 and 5 are corresponding angles. And then let's look 1 and 7. So if we have 1 and 7, are those, do you think they're alternate interior? Are they inside or are they alternate exterior? Or are they on the exterior of our parallel lines?
Are they alternate exterior?
They're alternate exterior. Yep, they're on alternate sides of the transversal and they're on the exterior of the parallel lines. Good. Okay, and then we have 6 and 8. So angle 6 and angle 8. Are those alternate interior, corresponding alternate exterior, or vertical? So 6 and 8, these ones. What do you guys think? Are they like any of the other ones that we already went over? Alternate interior, corresponding, or alternate exterior? Those are our vertical angles. So if you have two lines that cross, the angles opposite from each other are vertical angles and they are equal. So angle 6 and angle 8 are equal because they are vertical angles. And then let's look at 3 and 7. Do a triangle. So we have angle 3 right here and angle 7 right here. So this one's inside, this one's outside.
Are they corresponding?
Yep, those are corresponding. That's the bottom left angle from this line and the bottom left angle of this line. So yes, those are corresponding. Very good. And then angle 2 and angle 8. I'll box them. We have this angle 2 and this angle 8. They are both inside our two parallel lines. So those are which one?
Alternate interior?
Alternate interior. Very good. Okay, and our last question. So we have line M is parallel to line N. So it's telling us these are parallel. What is the measure of angle ABC? So we have to use what we learned about our angles. So if this angle is 50, we know this angle because these are alternate interior angles. So if this one's 50, what do we know angle A is also?
50?
Yep, we know that one's also 50. Very good. Okay, so this one's 75. This one's 50. Since these are parallel lines, they told us, M and N, then these are alternate interior angles, which means they are equal. If this one's 50, this one's also 50. And we are trying to figure out angle ABC. So this angle right here. So now we have a triangle. We know two of the angles. How can we find this third angle?
By adding up 50 and 75 and subtracting that from 180.
Exactly. Very good, Brendan. Yes. Triangle sum theorem. We know that these three have to add up to 180. So if we subtract, just like you said, 50 and 75 from 180, we will be left with angle B. So we can say 50 plus angle B plus 75, we know equals 180. So this is just the fancy way of showing your work. Exactly how you explained it, Brendan, is perfect. So 125 plus angle B equals 180. We subtract 125, and angle B is 55.